Let's set this one up. Do you guys know what kind of object this is, actually? Anyone have any thoughts as to what kind of object this is? Do you have any feelings, Sharon, what kind of object this is? I'm curious. No. What if I wrote it like this? What if I wrote it like this then? It's not a full circle. It's almost a full circle. If I want a full circle, I'd actually have to write this. When I solve and I take the positive square root, that's only half of the circle. That's the upper half of the circle. So really, this guy looks like this. The radius of the circle is going to be 1. So, oops. So this is going to be 1. This is going to be 1. And this is going to be -1. Oh, wait. This is not a good question. Let me help you with this, because if I'm not mistaken, this is not a good question. I think. Let me explain why. I have a semicircle that looks like this. Wow, that's not a good semicircle. I have a semicircle that looks like this. And they want me to use shells to find the volume of the region. Oh, we're okay. Sorry. Because x goes from 0 to 1. That's okay. That's okay. Because x go to 0 starts here. Oh, we're good. I was getting nervous. So this is the region that we're rotating. This region right here. How are we doing on time? Some time. We're rotating about, right, because it says x equal to 0 to 1, not from -1 to 1. If it's from -1 to 1, I was going to be very nervous. And I can explain why later. But we're going about the x-axis. So this time I want to put the loop right here. I want to give you some time to try this. All right. I gotta go to a meeting soon. Let's chop this up parallel to the axis of rotation. What do you guys think, dx or dy? I concur. Dy. Next, we have to ask ourselves, what's the smallest y could be? What's the lower limit of integration? 0, and the biggest is 1. I agree. 2 pi, what's the radius going to be? Y is correct. Here's the $1 million question, my friends. What's the height of the function going to be? We need to take this. This is part of, I kind of started it right here. Instead of having x be our independent variable, we want to manipulate this so that y is the independent variable. So I hope you guys can see that. Let me not fool myself later. I hope you guys can see that when you solve for y, this becomes y is equal to square root. We got to solve for x because we want everything to be in terms of y. So this gives us that x is equal to 1 minus y squared to the 1/2 power. So this equation is x equal to 1 minus y squared to the 1/2 power. 1 minus y squared to the 1/2 power. How do I integrate this? We can't distribute the square root. That's impossible. Doesn't work. So you can't solve it algebraically, which means you got to use u substitution. What should u be equal to, my friends? One minus y squared is correct. That makes du dy equal to negative 2y. This makes dy equal to negative 1 over 2y du. So we make our substitution. We're going to have, you have to change the limits of integration as well, right? So when y is equal to 1, that sends u equal to 0. When y is equal to 0, that sends u equal to 1. So your integral becomes the integral from 1 to 0, 2 pi. You're going to have a y there. You're going to have a u to the 1/2. And then you're going to have a negative 1 over 2y du. This is terrible form unless the y's cancel out, which they do. So I can really write this as the following. I can pull out the constant. I'm going to have 2 pi divided by 2. If I interchange the limits of integration, I pick up a negative. But I have a negative right here. So the negative times a negative is going to make that a positive. So there's originally a negative. When I flip it, it becomes a positive. I have u to the 1/2 du. Right? This becomes pi. The antiderivative of u to the 1/2 is u to the 3/2 times 2/3. You got to go from 0 to 1. My two favorite limits of integration. This becomes 2 pi over 3 times 1 minus 0, which is just 2 pi over 3. Units cubed.